mutual information. Mutual information. Already we know what is information. Now it is mutual information. This is related with both input as well as the output side characteristics. Output side characteristics. Now before that we have to define the entropies. First of all, we will define entropy for both discrete cases and then continuous cases. Entropy for continuous channel. Entropy for continuous channel. Say h of x, if the distribution is continuous, then instead of summation, we will use integration. Integration minus infinity to plus infinite. Instead of probability, here we will use PDF, probability density function, log base 2 fx of x, then dx. Usually log la varradhu 1 by la poduvom. அப்படி இல்லனா இங்க ஒரு மைனஸ் சைன் போட்டுட்டு டைரக்டா நியூமரேட்டர்ல கூட எழுதலாம். இப்படி எழுதலாம். இல்லனா இது 1 by ல போட்டாலும் ஓகே தான். h of x formula. Suppose if they are asking conditional entropy, what is the entropy of x given y? Conditional entropy. Minus infinity to plus infinite, minus infinity to plus infinite, f of xy, xy. This is giant PDF of x and y. Mostly x will denote input side, y will denote at the output side. Again, log base 2 f of x given y, dx dy is the conditional entropy. If it is instead of x given y, if it is y given x, here we will have change. Instead of f of x given y, here we will get f of y given x. That is the difference. So this is the formula of the entropy for the continuous channel and then conditional entropy for the continuous channel. Then for discrete case, what is the entropy? Conditional entropy. Say h of x given y for discrete cases. Instead of integration, we will use summation. Instead of PDF, here we will use probability, giant probability mass function, p of x comma y, and then log base 2 1 by p of x given y. Or if it is h of y given x, h of y given x, summation p of x given y, log of base 2 1 by probability of y given x. Okay, these are all the regular definition, regular formulas. Okay, so just we are seeing what is the formula for continuous channel, entropy formula. Then for discrete cases, what is the conditional entropy? So now we will relate this conditional entropy, then ordinary entropy with the mutual information, with the mutual information. See, what is the concept of mutual information? I am having some channel. Just now we have seen binary symmetric channel. I am creating symbols at the sender side, okay, transmitter side. Already it is having some uncertainty. I will at any point of time, I do not know at what symbol I will get. Okay, there is uncertainty. Then the symbols I am going to transmit over the channel. Again, the channel is noise will be introduced in the channel. So at the output of the channel, I will get y. Already I do not know what is the characteristics of x. Now I am introducing noise. Further, it will be modifying our information. Then I will finally get y. Now there will be uncertainty in y also. There will be uncertainty in y also. So mathematically, I know what is the uncertainty in x, that is h of x. Then I know what is the uncertainty in y. Then what is the effect of channel here? Okay, to define the effect of channel here we will be introducing the mutual information. Okay, the mutual information that is between the x and the y. So now I'll write the definition of IXY, that is the mutual information. IXY is the mutual information. XY is the mutual information. Say IXY, we can define like h of x minus h of x given y, or otherwise I y given x is equal to h of y minus h of y given x, h of y given x, h of y given x. So this is the mutual information. See here, suppose if y and x are independent, y and x are independent. If x is independent, again from the equation 2, you can write h. If y and x are independent, the entropy of y is really independent of x. So you will get h of y. Then the mutual information between x comma y is 0 if y and x are independent. So quickly using this, you can check the formula whether whatever the formula we have written is correct or not, because mostly we will get confused here, either y by x or x by y like that. So using this check, you can check the formula. So this is the definition of the mutual information. See, what is HY? HY is the uncertainty at the output side. Y means indicating the output. Now, what is H of Y given X? Okay, see, I know what I have transmitted. Then you find out the uncertainty. Okay, you have been informed what you have transmitted, what has been transmitted at the transmitted side, X. Then what is uncertainty? Okay, then once if you find the difference, definitely here there will be more uncertainty. Here there will be less uncertainty. Then the difference between two is the mutual information between these two, X and Y, mutual information between these two. Then there are some of the properties for this one, properties for the mutual information. The I of X comma Y is equal to I of Y comma X. At any point of time, mutual information can never be negative. This is mutual information is always greater than or equal to 0. Then I of XY, we can relate with giant entropy, that is H of X, then H of Y minus H of X comma Y. Instead of conditional entropy, here we are writing giant entropy. I of X comma Y is equal to H of X plus H of Y minus H of X comma Y. So for mutual information itself, I have written 3 formulas. Okay, say this is 1, 2, and then 3. There are 3 formulas. So now from all these formula, we can understand if in case if Hx is equal to Hy, okay, this is possible only when the channel is noiseless. Okay, if the channel is noiseless, there will not be any change in X and Y. The uncertainty in X and then uncertainty in Y will be same if both are same. Okay, H of X is equal to H of Y. By using all these 3 formula, you can understand H of Y given X is equal to 0. H of Y given X is equal to 0. Okay, if both are same, then conditional probability. What is the entropy uncertainty in Y given X? That is 0. Why? Because both are same. If both are same, definitely there is no uncertainty. Okay, so again, if you measure uncertainty, that will be 0. H of Y given X is equal to 0. This is all about the mutual information.